Okay, this is part 2 on every question asked by Edexcel. And this time it was on percentages, but we're going for part 2 is compound interest, and then a couple of problem solving ones that are at the end. So it says here that Anna wants to invest £25,000 for 3 years in a bank, and we've got these both things here. Both of them are compound interest. Which bank will give him the most interest at the end of 3 years? So I'm going to sort of split my page in two, and I'm going to do my personal bank over here. He's got £25,000 and he gets 2% for each year. So you need to think of the multiplier for this. The multiplier for 2% is 1.02. And because that's happening for 3 years, we're going to multiply it by 1.02 3 times, which is the same as 1.02 cubed. So I'm going to do 25,000 multiplied by 1.02 cubed to the power of 3. And we get that the amount of money is £26,530 and 20 pence. Now, the secure bank, so secure bank over here, the multiplier for 4.3% is 1.043, and for 0.9% is 1.009, because it's 100.9%. So we're going to do for this calculation, 25,000 times by 1.043, that's for the first year, and then 1.009 squared for those next 2 years, and then we're just going to do a comparison here. So 25,000, multiplied that by 1.043, multiply that by 1.009 squared, and we get the answer £26,546 and 46 pence. £26,546 and 46 pence. So we can see that out of these two numbers that we've got here and here, he will get more interest from secure bank. So secure bank gives more interest. Just because it's a bigger number, we don't need to explain that. It's pretty clear when you've got those two numbers. So we do have the 26,530 and 26,546. So we have got secure bank for that part. Okay, so it's another calculator question. We've got these two types of accounts, and we've got Ali investing £2,000 and Ben investing this £1,600. Work out who will get the most interest by the end of 3 years. So I'm going to do Ali's calculations first of all. 2.5% per annum, that means per year, that is 1.025. 3.5% is 1.035. So for Ali, he's putting £2,000 in, and we're going to multiply that by 1.025 to the power of 3. Let's find out how much he gets. That's 2,000 times 1.025 to the power of 3 that we have here. So he gets 2,153.78. So the amount of interest that he has earned is this amount minus 2,000. So I'm going to do 2,153.78, take away 2,000, which is obviously £153 and 78 pence. So now I'm going to do the calculation for Ben. Ben is doing 1,600 times 1.035 cubed. Let's find out how much Ben gets. Let's put the calculator to the other side. 1,600 times 1.035 cubed. And Ben gets 1773.95. So the interest that Ben gets is going to be that amount, take away 1,600 that he put in. So I'm going to do this all on my calculator, and the interest that he gets if I take away 1,600 is £173 and 95 pence. So we can now kind of confidently say who is going to get the most interest? Ben will. Because it's more. Okay, these are the two numbers that we're comparing here and here. In the third year, the rate of interest for the shares account is changed to 4% per annum. So we're looking at this one. Does this affect who will get the most interest by the end of 3 years? Give a reason for your answer. And we can say no, because the Ben already has more. So if we make the percentage more, he's going to have even more. No, Ben already has more than Ali. This change will increase it even more. Okay, let's check we've got it right. We have Ben, and we have the values that we had here, and the conclusion, yep, Ben is going to be correct. It's still going to be Ben. No, since the shares have been now 182. Actually, I think they wanted us to have a bit of a calculation. Does they give a reason? I guess we could do, if we wanted, a calculation of 1,600 times by 1.04 cubed, and we get the number that they've got here, which is £182.50. So if you need to, you can always do a bit of a calculation. Got another calculator one here of compound interest. Katie invests £200,000 in a savings account for 4 years, and we want to find out the amount of, she gets compound interest at a rate of 1.5% per annum, that's per year. So the multiplier is going to be 1.015. There's that extra 1.5% there. And we're going to find out the total amount of interest that she gets at the end of 4 years. So we're going to do 200,000. We're going to multiply that by the multiplier, which is 1.015 for 4 years. We'll calculate how much that is. 200,000 times 1.015 to the power of 4. So that's £212,272.71. So the amount of interest will be 212,272.71. Take away 200,000, and I don't think we need the calculator for that, do we? It's just going to be the £12,272.71. So in 4 years, that's quite a lot of money to have got from 1.5% per annum, but I don't know many people who have got £200,000 lying around in a savings account. Let's check we got it right. Yeah, £12,272, and they accept any of these answers just because of the way that people might have done some rounding. Okay, so this time we've got a bit of percentage change and some compound interest. So it says Nabi invests £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of the 5 years, it is worth £8,029.35. So it looks like we've got 6,000 is being multiplied by something for 5 years. I'm just going to say that it's not X%. Let's call it something different. Let's just going to say it's multiplied by some value for 5 years, and we get the answer £8,029.35. If we can find out what y is, y in this case is our multiplier. I think if we find out what y is, we can then use that to think about what the X% is going to be. So I'm going to try and solve this equation by doing £8,029.35 divided by 6,000, and we'll see what that comes up with. So we're going to do 8,029.35. I'm going to divide that by 6,000, and I get 1.338225. So y to the power of 5 is 1.338225. Now to find out what y is, I need to do the fifth root of this. The fifth root of this is a bit of a difficult one to find on the calculator, but I'll see if I can show you where it is. So the fifth root, if you look at where the square root sign is, mine is actually where the XY button is, this button that I've got here. So I'm going to just go on to the next section. I'm going to press Shift and then that, and I don't want to put the answer in there. Let's delete that bit. I'm going to do the fifth root, so there's a little 5, and it's 1.338225. And we come up with that y is 1.059999. In fact, it's basically 1.06. So 1.06 is the multiplier. Now, if we think about X%, compound interest X%, this means that our multiplier is 1.06. So I think that our value of X is just going to be 6% that we've got in this particular case, because 1.06, this represents an increase of 6%. So X is equal to 6. It doesn't actually need that percent sign that we've got there. So we do come up with 6%, but you could have put 5.99 because of the way that things have been rounded. Okay, these are some much more tricky kinds of compound interest questions. They are got some extra elements to them. So Jean invests £12,000 in an account paying compound interest for 2 years. In the first year, the rate of interest is X%. At the end of the first year, the investment is £12,336. In the second year, the rate of interest is X over 2%. What is the value of Jean's investment at the end of 2 years? Well, I'm going to split this into 2 parts. So we know that 12,000 is going to be multiplied by something. Again, I'm going to say that y is my multiplier, and then we'll use that to help us find out what x is. It's being multiplied by y, and we get the answer of 12,336. So the multiplier is going to be 12,336 divided by 12,000. Let's see what that comes up with on my calculator. 12,000. Let's clear all of this because it's getting a bit busy. We're going to do 12,336 divided by 12,000. So the multiplier is 1.028. Now 1.028 means that the percentage is going to be, it's an increase of 2.8%. In other words, x is equal to 2.8. So in the second year, the interest rate is x over 2. So for the second year, x over 2 is not going to be 2.8% anymore. It's going to be 1.4%. Now 1.4% as a multiplier is multiplying by 1.014. So I'm going to take the amount of money that they had at the end of the first year, which was 12,336. I'm going to times it by our multiplier for the second year, and that should tell us how much Jean has got in the account. So I'm going to do 12,336 multiplied by 1.014, and the amount of money is £12,508.70. I'm just rounding that at the end there. Let's check that we've got this right. £12,508.70. So that's pretty good there. Okay, we've got percentage change and compound interest again. We've got these questions coming up quite a lot, so you really do need to know what's happening. So in 2009, the value of the company that Mr. Veal bought was £50,000. Each year, the value of the company increased by 2%. Calculate the value of the company at the beginning of 2017. Give your answer correct to the nearest £100. So each year, I think we should find out the number of years that this has been invested for. So the number of years, I'm going to do my 2017, take away 2009, which is going to be 18 years. So the value of the company at the beginning of 2017 is going to be £50,000, and that's going to multiply by increasing it by 2%. The multiplier is 1.02. We're going to do that to the power of 18, and then we're going to do that to the nearest 100, okay? So 50,000 times it by 1.02 to the power of 18. So it wants it to the nearest £100. That is going to be £71,400 for that first part of the question, okay? Let's check we got that one right. Oh, no, we didn't. Why have I put 18 years? Of course that doesn't make any sense. As if this is 18 years. I hope that you were screaming at the screen when I did this. Of course, it's not 18 years. The difference between 2009 and 2017 is 8 years. So I'm going to go back and just adjust this. It is 8 years, so it is £58,600 when we round that to the nearest 100. What did I just say? 58,600. Good job, I checked that. And good job I've got the mark schemes for all of us to use when we do these questions. So this one's worth a few more marks. This one's worth 3 marks. At the beginning of 2009, the value of a different company was 250 grand. And in 6 years, the value of this company increased to £325,000. This is equivalent to an increase of X% each year. So I'm going to use Y again as my multiplier. And we're going to do the same setup as a couple of questions ago. So I'm going to say that 250,000 multiplied by my y to the power of 6 gives us £325,000. Now I'll find out what that is by doing a division. I'll do 325,000 divided by 250,000. I had a missing 0 there. And we get that y to the power of 6 is 1.3. So y is going to be the 6th root of 1.3. The 6th root of 1.3. Let's put the calculator on this side. So I'm going to do shift and my xy there. Let's change that so it doesn't say answer. It is the 6th root of 1.3. And we get that y is 1.04469. Now this thing looks to me like an increase. It wants it to 2 significant figures. It's an increase of, this bit here looks like it's going to be of 4.5% per year. So that means that our X percentage is 4.5 for 4.5%, okay? Did we get it right? Yes, we did. And we did get that one right once I spotted it was 8 and not 18. Okay, we've got more tricky compound interest stuff. So Sakira invested $3,550 in a savings account for 3 years. She was paid 2.6% per year or per annum for each of the first 2 years and R% interest for the third year. She had a total at the end of the 3 years, work out of 3,819.21 at the end of 3 years, work out the value of R. So again, I'm going to use my Y to represent the multiplier, and then we'll figure out what the value of R is from there. You could do it in another way. This is just the way I think is the easiest. So she's getting 2.6%, which is 1.026. That's for 2 years. And then we're going to have that Y multiplier. And then she's left with £3,819 and 21 pence. So to find this out, I'm going to do £3,819.21. I'm going to divide it by the 3,550. And I'm also going to divide it by the 1.026 squared because I want to divide it by this thing and this thing, okay? So, keep putting the answers up, which is annoying. I'm going to do 38, let's clear this again so I've got more space, 3819.21 divided by 3,550 divided by 1.026 squared. And we get that the multiplier for Y is let's just tuck that away a second so I can get my pen back, is 1.021998. Well, because it's going to want it to just one decimal place, it looks like this thing here is representing an increase of 2.2%. This bit here is the percentage part. That's going to be an increase of 2.2%, which means our value of R is 2.2. So we do have the answer of 2.2 there. Let's clear this calculator and put it to this side. Okay, we have got one more on compound interest and one on depreciation, and then 2 problem-solving questions. This is quite a long video. So Tariq buys a laptop. He gets a discount of 5% off the normal price, and he pays £551 for the laptop. Work out the normal price. So this isn't compound interest. This is just reverse percentages. So the normal price, he gets 5% off, which means it's being multiplied by 0.95. And that gives us 551. So to go backwards, I'm going to divide by 0.95. So I'll do 551 divided by 0.95 to get the original price of this laptop. 551 divided by 0.95 is £580. Now you can't just subtract, you can't just add 5% back on, you have to use this method. Here comes some compound interest part that we've got here. It says Joan invests £6,000 in a savings account, and these are the interest rates we get. Work out the interest at the end of 3 years. Well, this is nice and easy. It's just 6,000 times 1.024 times 1.017. Oh, hang on, each extra year. So that's going to be 1.017 squared to represent those 2 years that we've got there. Definitely easier than the previous questions. 1.017 squared. So that is £6,354 and 67 pence. Let's check that we've got that one right. Yep, we do for both of those questions. Okay, this is now a depreciation question, which is kind of the same idea as compound interest. It's just about things going down rather than increasing. So Jack bought a new boat for 12.5 grand. The value, V pounds, of Jack's boat at the end of n years is given by this formula. At the end of how many years has the value of Jack's boat first less than 50% of the value when it was new? Well, there are other ways of doing this, but I think this is a good one for a calculator paper of doing a bit of trial and error. So less than 50% of how much it was when it's new, 50% is half, and a half of £12,500 is going to be £6,250. So I'm just going to try different values of n until it's less than 6,250. So I'm going to do on my calculator, 12,500 multiplied by 0.85 to the power of, 5. Oh, that's definitely gone too low. Let's try to the power of 4. That's actually too high. So we can write down here, if n equals 4, the value is 6,525. And if n equals 5, we get 5,546. So that's the first time that it goes less than 50%. So after how many years? It was going to be 5 years for that one. Then it's got something different for part B. A savings account pays an interest rate of R% per year. Jack invests 5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20. So this has kind of got a bit of a reverse percentage question before we do the previous part. So this £79.20 is the 60% because 40% of it he's had to pay elsewhere. So £79.20 is the 60%. Now, if you want to find out what 100% is, you could do this in a different way. You can find out what 10% is and then what 100% is. In other words, you can divide it by 6 and then times it by 10. Now, I'm going to just do that in one calculation. I'm going to divide it by 6 and I'm going to times it by 10. So, calculator coming back, we're going to do £79.20 divided by 6 times it by 10. So that actually means the amount of interest that he got paid was 132. So we're going to find out just for 1 year the amount of interest that he got. We're going to do the interest divided by the savings, and that's going to give us the percentage. It's going to be 132 out of 5,500. It's going to give us a multiplier here. 132 out of 5,500. That's 0.024. 0.024. Now, if you're good with multipliers, you'll recognise that this is equivalent to 2.4%. And so the value of R is 2.4. Let's check that's right. 2.4. And for the first part, we have 5. Okay, this question is pretty hard. It's a non-calculator one as well, and it's sort of general problem solving. It says that Jack and Sadia work for a company that sell boxes of breakfast cereal. The company wants to have a special offer. Here is Jack's idea for the special offer. Put 25% more cereal into each box, but do not change the price. Here is Sadia's idea. She wants to reduce the price, but just keep the amount of cereal in each box the same. Sadia wants her idea to give the same value for money as Jack's idea. By what percentage does she need to reduce the price? Now, this question is going to be made so much easier if we can actually just pretend how much cereal is in the box and how much it's cost. So, for example, we're just going to pretend that 100 grams of cereal costs £10. And you'll see I've picked some really nice numbers there to make it really easy. But it doesn't have to be these numbers. I just think 110 are quite good ones to work with. And obviously, no one's going to want to buy this cereal, but it's still going to give us the correct proportional things. So what Jack is going to say is he wants to put 25% more cereal in. So Jack is going to say that 125 grams of cereal is going to cost £10. Okay, that's what Jack is going to say. And Sadia wants to make sure that there is 100 grams in there, and we just need to find out what the cost will be because we want to have the same value for money. So to try and spot how do I go from 125 to 100 grams, there's a little helpful in-between stage of going to 25 grams. Now, to go from 125 to 25, 25 goes into 125 5 times. So if I divide this side by 5, I'm going to get that 10 divided by 5 is £2. Now, because Sadia wants there to be the original amount, which is 100 grams, I'm going to times that by 4, and I'm going to times that by 4 on this side, so that Sadia is saying it should cost £8. So we need to think about what percentage she wants to reduce it if it's currently costing £10 and we want it to reduce to £8. Well, that's a pretty simple one to think about that it's going to reduce by. It's a reduction of 20% that we've got there. And we're going to finish this. Here's our correct answer of 20. We're going to finish this section with another non-calculator problem solving that kind of didn't really fit anywhere else. And we're just going to read through this question, and it is non-calculator. So a bonus of £2,100 is shared by 10 people who work for a company, but it's not shared equally. 40% of the bonus is shared equally between 3 managers. So let's pause there. We're going to work out 40% of 2,100. Tons of ways of doing this. 10% is 210. So 40%, if you times that by 4, is 840. That bonus is shared between 3 managers. So I'm going to do 840 divided by 3. Let's see how much 3 goes into 840. 3 goes into 8 twice with 2 left over, and 3 goes into 24 8 times. So it is 280. So I'm just going to write down how much everyone is getting here. So the managers, they get £280 each. The rest of the bonus is shared equally between 7 salesmen. Okay, so the rest of the bonus, that means that there was 840. The rest of the bonus for the salesman is going to be 2,100 take away 840. So I'm going to do 2,100, take away 840. I'll take that 1 and I'll borrow it. 10 take away 4 is 6 and 20 take away 8 is 12. So that's 1,260, but there are 7 salesmen. So I need to do 1,260 divided by 7. 7 goes into 12 once with 5 left over, and 7 goes into 56 8 times. So the answer is £180. So the managers are getting £280 each. Let's just move this down here. The managers are getting £280 each. That might be useful. I haven't even read the whole question. And the salesmen are getting £180 each. Now let's read it. One of the salesmen says, if the bonus is shared equally between all 10 people, I will get 25% more money. So let's see if it was equal sharing, okay? Equal sharing between all 10 would be 2,100 divided by 10, which is £210. Now we need to find out of 25% extra of 180. So I'm going to do 25% of 180. That's just a quarter of 180. And half of 180 is 90, so a quarter is going to be 45. So if I do 180 plus 45, which is how much he thinks he's going to get, that is £225. So he thought that if he got shared between 10 people, he would get 25% more money. He thought he'd get 225, but it's not that. So is the salesman correct? Using these two values that we've got here, as they are not the same, the salesman is incorrect. So the salesman is incorrect. Okay, let's double check that we got that right. So yeah, the salesman is incorrect. It says no. And we've also got the comparison of this 225 and the £210 that are down here for this. Now this was a long video because percentages is a huge area. The next one I'm going to be doing is on ratio, which is probably an even bigger area. But this is going to be a really good resource for you for your revision. So I will put a link to this document in the description so that you can access all of these questions, practice them yourself, and then just come and use my videos to see how they're done. Wishing you the best of luck for all your studies, and yeah, subscribe to my channel and make sure that you're going to keep following with all the stuff I'm putting out for you.